In this video, we will talk about p-values and significance. In most of the output that you're going to see, the word significance is going to be there. It's going to be S-I-G period, or it could be significance, and in parentheses it could say two-tailed. It is the same thing. The first word up is alpha. It's a little a. Before you run any statistical test, you must first determine the alpha level, which is called the significance level. By definition, the alpha level is the probability of rejecting the null hypothesis when the null hypothesis is true. Translation, it's the probability of making a wrong decision. Thanks to famed statistician R.A. Fisher, most folks typically use an alpha level of 0.05. Like all probabilities, alpha ranges from 0 to 1. This is kind of an abstract area of thinking, but you need to understand the magic number. Listen to the words I'm saying. The magic number is 0.05. Okay? We are looking at a 5% chance a 5% idea that it happened by chance, leaving 95% confidence. P-value. We'll be using this word a lot, so you really need to understand it. 0.05 is what we use. It's the observed level of significance. It can be P is either greater than or less than or equal to 0.05. In this case, here's an example. P is greater than 0.05, which means when you're looking at your data and the significance, if it says 0.060, it is P is greater than 0.05. We don't give the number, we give it's either greater than or less than 0.05. We are saying there's a 5% chance P is set to 0.05 is occurring by chance. Non-significance, okay? This is when the P is greater than 0.05. It's non-existent. We reject the null hypothesis. Does not mean the null is true. And non-significance tells us the effect is not big enough to be other than chance. Significance is when it's below 0.05. It's significant. We reject the null, accept the alternative. If there's an assumption, there is an assumption that the null is false. If the P level is low, the HO must go. So if the significance was 0.010, okay, that's telling you that it's under 0.05, and you would have to reject the null, accept the alternative, and it is significant. The p-value approach to testing, probability of obtaining a test statistic equal or more extreme than the observed sample value, given the HO is true. Okay, the p-value is also called the observed level of significance. It is the smallest value of alpha for which the null hypotheses can be rejected. If the p-value is below 0.05, we reject the null hypothesis. If the p-value is above 0, we do not reject the null and we accept the alternative. Again, here's that little thing. If the p-value is low, the null must go. Here are the 5 steps to the approach to testing. State the null hypotheses and the alternative. Choose a level of significance, and that's what we're talking about here is 0.05, and we'll pick the number of participants basically. Determine the appropriate test statistic in the sampling distribution. Collect the data. Compute the test statistic and the p-value, which is basically the p-value, and make sure that there's a statistical difference. If the p-value is low, reject the null. Otherwise, do not reject the null, accept the alternative, and then give a conclusion. So here's an example. We're going to use the bold is 30. Okay. In this case, we have a null and an alternative. The null is 30. And the alternative is it's not 30. Okay, it's a two-tailed test, which means that in a normal distribution, the tails on either end are going to show 0.025 on one side and 0.025 on another side. Specify the level of significance. We're going at 0.05, and there was 100 bolts used for this test. Is the p-value under A? So in this case, it's going to be 0.0456, which is under A. We would reject the null hypothesis. State the managerial conclusion in the context of the situation. So basically, it's a conclusion. There is sufficient evidence to conclude that the average diameter of a manufactured bolt is not equal to 30 millimeters. Here's another one. Example of a two-tailed test. The average cost of a hotel room in New York is said to be $168 a night. To determine this is true, a random sample of 25 hotels is taken and a result of X of $172.50. So basically, the X means that when they did the 25, they got an average of $172.50 and an S, which is standard deviation of 15.40. I'm sorry, $15.40. Test the appropriate hypotheses at 0.05. So you see our null and our alternative. Our null is it will be equal to 168, and the null is not equal to 168. So you'll see on the left here, there's the null in the alternative. The alpha is at 0.05. There's the n is equal to 25 participants. The DF is 25 minus 1 because 1 is available, so your DF is 24. Okay, the p-value is at 0.071. So we do not reject the null hypothesis. It's above 0.05. We do not reject the null hypothesis. There's insufficient evidence that true mean cost is different than $168. Okay, you need to study these because some of these will be on your test. Okay, statistical significance versus practical significance. Statistically significant results rejecting the null hypotheses are not always practical significance. This is more likely to happen when the sample size gets very large. Practical significant results might be found to be statistically insignificant, failing to reject the null hypothesis. This is more likely to happen when the sample size is relatively small. So sample size has a great deal to whether you have answered the question correctly. So sample size is something where, and then basically sample size is how many people you're picking for your study. So it's very important that you're picking the right sample size, you're picking the right alpha, and you're running the correct test. Reporting results, make sure you study this. And there's some ethical things that you need to understand because those will be on your test.